Okay, this is going to be our last video in the place value series. If you recall, we've been going over different concepts of place value for about the last few weeks, and we're going to wrap it up today. Before I do that with you, though, let's review what we've already talked about. We've talked about how what place value is, the difference between a number and a digit. We've talked about the hundreds, tens, and ones pattern. We talked about how commas separate numbers into sections. We talked about standard form, expanded form, word form of a number. We talked about place value in real life situations. Zero as a placeholder and as a factor in multiplication. We also talked about place value blocks and what they represent. And I have some out with me now that I'll share with you in a minute because it ties into what I'm going to show you today. Okay? If you notice, I made this little chart or table. I've written a 4-digit number on the top, and I've made a little graph here. Okay? More of a chart, like I said. What's the number at the top? Well, let's see. Reading it from left to right, 1. When I see a comma, it means what? 1,000. 1,573. Right? 1,573. Now, this means, remember, this one is not a 1, it's a 1,000. This 5 is not a 100, it's not a 5, it's a 500, right? This 7 is not a 7, it's 7D, or 7 tens. And this 3 is 3 ones, right? Of course, the comma. So basically, once again, breaking it up into the chart, 1,573. 1,000s, 500s, 7 tens, and 3 ones, right? In place value blocks, what would it look like? 1,000, right? 500s, 7 tens, and 3 little ones, right? Okay, that's the easiest way to do it, to break it down. I want us to use our imagination now and pretend that we did not have any thousands. What if we did not have this thousands cube, but we had everything else? We had enough of everything else to still make this number. Okay, what would I have to do? So I'm going to put an X here. Remember, pretend I don't have 1,000 now. How would I build this number still? Can I do it? Yes, I can, if I have enough of the other things. I'm going to keep the 3 ones there. Right? I'm going to keep the 7 tens there. Okay? Now, you'll notice all I have left is this hundreds column. Yet I've got 2 digits, a 1 and a 5. Can't do anything here. I don't have 1,000. I have only one choice, and that is to put both the 1 and the 5 in this square, so I have a 15. Okay? And that is correct. I need 15 hundreds, 7 tens, and 3 ones to make this number. Why is that? Well, let me explain. You still have your 3 ones. Like I said, you still have your 7 tens. But remember, I don't have this anymore. But what I do have in its place is enough hundreds to make up for it. My question is, how many of these 100 squares would fit into this 1,000? Well, like I said, every time you go to the left, you're multiplying by 10. You're adding a 0. That's the power of 0, right? So how many of these 100 squares fit in here? Well, 100 times 10 is 1,000. So I would need 10 more of these to make up for this cube. It's like I took 10 more of these, glued them together to make this. Okay? Plus the 5 that I already had. So what's 10 plus 5? 15. And there it is. So even though I don't have a thousands place to deal with, the thousands digit can move in with the hundreds digit. Because technically this number still has 15 hundreds. It's just that here they were separated. Here you had 10 put together to make 1,000 and the 5 left over. Now I'm taking these 10, putting them together to make 15 with the 5. Okay? Let's take it a step further now. Let's say that I didn't have any thousands or hundreds. Now what do I do? Well, I still have my 3 ones. These don't go away. The ones are always what they are because they're the smallest unit in this case. Now you'll notice I have a 1, a 5, and a 7. 3 digits, but only 1 square. And yes, I put all 3 digits in this 1 square. This 10's, it's actually a 10 square. Don't want to confuse you. But in 1 space. 157 is going in the tens place. 3 stays in the ones. Why is that? Well, let me show you that. Remember, you're multiplying by 10 every time you go up to the left. Okay? Like I said, these are the faithful ones. These never go away. These are the ones. Now, I have 7 tens already. So the 7 is here. Now, the 500s, I no longer have hundreds anymore. So what do I have to do? Well, let me ask you this. How many of these little 10 sticks fit in a 100 square? Remember, you're multiplying by 10. 10 times what is 100? 10, right? So basically, I would need 50 more of these little 10 sticks to make up for these. Because there are 10 sticks in each one of these. 10 times 5 is 50. Okay? So it's the 50 plus the 7 of these I already had. That's 57. Now, remember, I don't have hundreds. How many more of these would I need to make up for the 1,000? Well, let me ask you this. If 10 of these fit in here, and 10 of these fit in here, how many of these would fit in here? This is a 10, it's got 1 0. This is 100, it's got 2 zeros. This is 1,000, it's got 3 zeros. I already have 1 0 here, I need to get to here. 1 to 3, how many more zeros would I need? 2 more zeros. What number has 2 zeros? 100. 100 of these would fit in this cube. Just like 10 of these would fit in this cube. Okay? So what I'm telling you is that I would need 100 more plus the 50 plus the 7 to make up for this lost ground. 157 tens in all, plus those 3 little ones to make that if I didn't have these. Thousands and tens, thousands and hundreds. Okay? Let's do one more step. I don't have thousands, I don't have hundreds, and I don't have tens anymore. All I got are these. A bunch of these. I have only one thing I can do. Yes, all 4 numbers, or all 4 digits, go in that place. Yes, if I had enough, I would need 1,573 of these little guys to make the number. Right? Because remember, the number of ones in a number, no matter how big it is the same as the number itself. 1,573, I would need that many ones. Here are my 3 ones. If I broke these apart, here are 70 more ones. If I broke these apart, here are 500 more ones, just glued together, broken apart. If I needed the rest of them, here's 1,000 more ones, glued together to make this, and broken apart to show you 1,573. Notice the pattern: 1573, 1573, 1573, 1573. What I'm trying to say is there are many ways, or several ways, that you can build a number with place value blocks or visualize it without having to just use what they say. See, when I was going to school, this is what we learned, just the top row. We didn't take it to the next level and say, well, what if I didn't have thousands? What if I didn't have hundreds? Okay? This is how you do it. You move to the next door neighbor. Each digit moves down. Says, all right, I'll go next door. I need to be there because I can't be with the other. I can't be with the thousands, the hundreds, because they're not there. Think of it like money. You have a dollar bill. That's a dollar, right? How many quarters make a dollar bill? 4, right? What if you didn't have quarters? What could you use? You could use 10 dimes. You could use 20 nickels. Or you could even use 100 pennies. Like this. Right? There are many ways to make a dollar. Just like there are different ways to make this number. Okay? Let's do one more example. Just to review. I'll do another 4-digit number. Do a different one. Okay. Here's the number. Okay, sorry about that. There's the number. How will we say it? 3,641. Right? 3,641. Okay. What if I didn't have any thousands? What would I do? 1 stays there. 4 stays here. But what goes here now? Not just the 6, but the 3. I could use 3,600 squares, 4 10 sticks, and 1 1 block. Next level. No thousands, no hundreds. What would I do now? 1 stays the same, but now all I got is this 10 square. What will go there? Yep, all the rest of the digits. 3 6 4. So I would need 364 of the 10s plus 1 cube, and I still have the number. Last step, of course. No thousands, no hundreds, no tens. What do I do? Only got one choice. All the digits go in the ones place. So I could use 3,641 ones, and it would still work. Okay? So once again, 3,641. I could use 3,000 cubes, 600 squares, 4 10 sticks, and 1 1 cube. I could use 36 hundreds squares, 4 10 sticks, and 1 1 cube. I could use 364 10 sticks and 1 1 cube. Or if all I had was the ones, I could use 3,641 1 cubes. Granted, it would be a lot. Probably take over the whole table. A lot of work, a lot of counting. But you get the idea. It's like taking $1 and saying I don't have anything but pennies. You need 100 pennies to make that $1, right? That's what I'm saying. It might be a little bit too absorbed. You might want to go back, pause, rewind, do what you have to do, take notes, make up your own maybe, right? You can draw out the place value blocks if you want, whatever you find helpful, okay? That's just another way to break up numbers, or different ways to break up numbers if you don't have thousands or hundreds, so on and so forth, okay? That's all I want to share with you. That's the end of this particular place value series, but you'll be seeing it a lot more down the line in other things we do. And hopefully you'll remember everything that we've talked about. You could always go back to the old ones as well. All right? I hope you found all this helpful, and I'll see you later.